Okay, in this podcast we're going to talk about making ionic compounds that contain metals where you can't predict the charge, or ions specifically that have elements that form more than one type of ion. So we had looked at everything in group 1 forms a charge of +1, everything in group 2 forms a charge of +2, aluminum +3. The group 17 here is -1, -2, -3. So what about all the other metals? So as it turns out, all the other metals, except for these 4 that are identified, can form more than one ion. So they might form a +1 ion and a +2 ion, or a +2 and a +3. So you have to specify which ion for that element is involved. Okay, so these you have to know. You need to know group 1s are 1, group 2s are +2s, everything that's identified here. Easy way to remember is silver is 1. Silver is always a +1. Zinc is a +2. Aluminum is a +3. These 3 you have to know, but they go 1, 2, 3. Okay, so what about the rest of them? How do we deal with that? So in the transition metals, which are actually 3B through 2B here, are transition metals, plus these other guys, you can have more than one possible charge, so you must have a Roman numeral to indicate the charge of the ion. So for instance, for copper, it can form a copper +1 or a copper +2 ion. And if it's got a copper +1 ion, we indicate that with a Roman numeral, copper +1 or copper +2. Just like iron, which can make an iron +2 ion or an iron +3 ion. So we list it as iron +1 or iron +2. So if we are naming a formula, an ionic compound for a metal that has more than one ion, we need to use Roman numerals. So that would apply to any metal except group 1 and 2, and then those exceptions. We don't ever do anything with cadmium, so don't worry about that, but silver, zinc, and aluminum. Silver's +1, zinc's +2, aluminum's +3. So if they're not in group 1 or 2, and they're not one of these exceptions, we need to use Roman numerals. So for instance, iron plus iron 3 chloride, in order to get a neutral charge here of 0, because the chlorine is a -1 and there's 3 of them, my negative charge is a -3, which means that the iron must be a +3. So to name this, it's going to be iron 3 chloride. It's important that you indicate the charge of the ion here and not the subscript. It is not the subscript. It's a common mistake students make. So copper chloride, chlorine is a -1, so copper here must be a +1, so it's going to be copper Roman numeral 1 chloride. Tin fluoride, the fluorine each are -1 for a total of -4, so tin must be +4, so it's tin Roman numeral 4 chloride or fluoride. Lead chloride, let me see, the chlorine is -1, there's 2 of them, so that's -2, so lead must be +2 chloride. And then iron sulfide, the sulfur, each sulfur is a -2 for a total of -6, so if there are 2 irons, they must each be +3, so it's iron 3 sulfide. There are actually 2 naming systems for naming the cations from transition metals. And you will often see, if you look at a container, that the original container that a chemical comes in, that it uses this method. I'm not going to make you remember them, but instead of iron 3, for instance, it would say ferric, and the iron 2 would be ferrous. And the way it worked was the one that has the lowest charge is us, and the one that has the highest is the ic. But like I said, I'm not going to make you memorize these, but you may see them, and there are keys, tables like this you can find as reference if you need to translate from one of these to what the formula must be. Alright, so let's take a look. So we have, here we have iron with bromine. So if the bromine is a -1, it must be a total negative charge of minus 2, so the iron must be a plus 2, so this is Roman numeral 2. Copper is a minus 1. Chlorine is a minus 1, which means copper must be a plus 1, so this is a 1. Tin oxide, oxygen is a minus 2 for a total negative charge of negative 4, so the tin must be a plus 4. So this is tin, 4, oxide. Okay, here's an iron oxide. This is a minus 2 for a total negative charge of negative 6, so this must be a plus 3. And as you can see, this is the reverse crisscross, right? 2 and 2, 3 and 3. So this is iron, 3, oxide. Don't make the mistake of putting the Roman numeral 2, which is for the subscript. This is the charge. Iron 3 oxide happens to be rust. There's different iron oxides, but the one that is orange and forms on iron when it rusts is rust. Alright, this is mercury sulfide. So if this is a minus 2, each of these mercuries must be a plus 1, so it's mercury 1 sulfide. So we're going to stop there.